Greetings of the day. I am Mrs. Deepthi P, working as Assistant Professor in Department of Computer Science and Engineering, Madanapalle Institute of Technology and Science. Here, I am here to give an introduction to a topic, exception handling in Java. So before coming to the topic exception handling in Java, we have to know what an exception is. So an exception is an abnormal condition that arises in the code sequence at runtime. So during runtime, they may have the occurrence of errors. At the same time, some abnormal conditions may occur. So it can be considered as an unexpected event which can occur during the execution of a program or at runtime. So this unexpected event which occurs at runtime may disrupt the normal flow of the execution of the program, and it may sometimes also lead to the abnormal termination of the program itself. So any unexpected event that occurs at the runtime or that the execution of a program can be considered as an exception, or else we can say that it is an object which is thrown at runtime. So if an exception occurs, there should be a mechanism to handle this exception. So as we all know that there may be the occurrence of errors during the program execution. So there will be some mechanisms to handle the runtime errors. So here also we will be having mechanism to detect the exception and also to report this exceptional circumstances so that we can take appropriate actions. So exception handling refers to the mechanism which handles or which reports the exceptional circumstances that occurs during the execution of a program so that we can take appropriate actions to handle these exceptions. So in exception handling, it can be considered as four types, not four types, it can be considered as four cases. So first thing is we have to find the problem, and it can be called as hit the exception. And after finding the problem or the unexpected event, we can inform the system that an error has occurred. So that is known as throwing the exception. So informing the unexpected circumstances can be considered as throwing the exceptions. And after that, we have to get the error information. So receiving the error information or whatever circumstance has happened can be considered as catching the exception. And finally, we have to take the corrective actions to handle the exception. So these are the four important terms that we have to consider: hit the exception, throw the exception, catch the exception, and handle the exception. So all these can be considered as two segments. In the first segment, we have to detect the errors and we have to throw the exception. And in the second segment, we have to catch that exception and we have to take appropriate actions to handle that exceptions. So the entire events exception handling can be considered as two separate sections which include detecting the errors and throwing the exception. And in the second phase, we are catching the exception and we are taking appropriate actions. So for example, we are considering a code segment. Here we have given seven statements. So as a normal flow of execution, it starts from statement 1 to statement 4, and when statement 5, an unexpected event has occurred. That is, an exception has occurred at statement 5. So what the condition will be? So whenever an exception occurs at statement 5, statement 6 and 7 will not be executed until otherwise the exception that occurred at statement 5 is not properly handled. So here we have to go through the hierarchy of Java exception classes. So considering the Java exception classes, the java.lang.throwable is considered as a superclass of all the errors and exceptions in Java. So this java.lang.throwable is inherited by two subclasses. First one is exception and the second class is error. So this is the hierarchy of Java exception classes. So first one is exception and the second one is error. These two are inheriting the properties from java.lang.throwable. So in exception, we can consider IO exception, SQL exception, class not found exception, runtime exception. So the most important one is runtime exception, which includes arithmetic exceptions, null pointer exception, number format exception, and array index out of bound exceptions. Index out of bound exceptions can be considered as two: array index out of bound exception and string index out of bound exception. And in the second class, error, we can consider stack overflow error, virtual machine error, then quit of memory error. So the most important one is runtime exception, which can happen at any time during the execution of the program. So here are the different types of exceptions in Java. The first category is checked exception and the second one is unchecked exception. So coming to the first category, checked exceptions, it is extended from java.lang.exception class. So this type of exception, it can be explicitly handled in the code itself with the help of try-catch blocks. So for handling this type of checked exceptions, the programmer itself have to handle this exception. For that, we are seeking the help of try-catch blocks. So this type of exception can occur at compile time. So they are also known as compile time exceptions or static time exceptions. So it has to be handled by the programmer itself. So this type of exception, it cannot be ignored at the time of compilation. So here appropriate action has to be taken for handling checked exceptions, which can be handled with the help of try catch block, which can be written by the programmer itself. The second category is unchecked exception, which is not handled in the program code. So the Java virtual machine or the JVM itself handles these unchecked exceptions. And again, it is extended from java.lang.runtime exception class. So these exceptions which occur at runtime are also known as runtime exceptions. So this type of exception include programming bugs, which includes logic errors or improper use of any application program interface. So these type of exceptions or runtime exceptions can be ignored at the time of compilation. So here the programmer not necessarily have to handle these type of exceptions. In effect, the JVM or the Java virtual machine itself will be handling these type of exceptions. So as I have already told, for handling checked in exceptions, we are using try catch block. So here we are considering Java try block. So we are writing, the programmer itself is writing this try block in a program. It is written within a method in a program. So this try block is used to enclose the code that might throw an exception. So whenever there's a chance for occurring an exceptions, we are writing those statements or those code inside the try block. So whenever we are writing any try block, it must be followed by either a catch block or a finally block. So without writing a catch block or a finally block, this try catch block is incomplete. So if we are writing only try block, the exceptions that are occurring in the try block is not caught properly. So after writing the try block within a method, we have to write Java catch block. So in the catch block, we are writing this catch block to handle the exceptions that may occur in the code written in the try block. So it must be used after the try block only. So without writing any try block, we can't write the catch block. It will not be considered for execution. So we can use multiple catch blocks within a single try. So if we are including many statements in a try block, if there is any chance for any multiple type of exceptions to occur, we can use multiple catch block for a single try block. So this is how a programmer can handle checked in exceptions with the help of try catch block. So this is a sample, this is syntax of writing the exception handling code by the programmer. So we have to write the keyword try followed by the statements that is to be written in the try block, which may cause or which may generate exception, which can be followed by catch block. In that catch block, we are giving the parameter as the type of exception with its objects E. Okay, and the statements which process the exception is written inside the catch block. So this is syntax of writing try catch block. So either try can be followed by catch block or try can be followed by finally block. So here I am considering the example of try catch block only. So this is the working of Java try catch block. Here we can consider so many scenarios in which an exception can occur. A simple scenario and the most common scenario is the case of arithmetic exception. So here I am considering an example. Int data is equal to 10 by 0. So as we all know, division by 0 is not defined. This may cause an unexpected circumstance. So here this condition int data is equal to 10 by 0 will cause an arithmetic exception since division by 0 is not defined. So there is a chance. So here surely there is a chance of occurring an exception. So after finding the exception, it throws an object of exception class is thrown. So after throwing the exception, we have to check whether this exception is properly handled or not. If the exception is properly handled, then rest of the code statements or rest of the statements following that exception will be executed. If it is not properly handled, then JVM printouts the exception description and it prints the stack trace and it terminates the program. So we have to write proper mechanisms to handle exceptions. So here first the JVM first checks whether the exception is handled not or not. If it is not handled properly, then if the exception is not handled properly, then the exception handler, then the default exception handler provided by the JVM will do some task like printing the stack trace and then it will terminate the program. If exception is correctly handled by the application programmer, then the normal flow of application is maintained. That is, the rest of the statements written after that statement will be executed and the normal flow of execution will be continued. So here we are considering the case of multiple catch block. So there is a need for writing multiple catch block statement if there is a chance for occurring multiple exception. So if we are writing a code which may cause arithmetic exception and which may cause array index out of bound exception in a single catch block, we have to write multiple catch blocks. Or if we have to perform different tasks at the occurrence of different exceptions, we use multi-catch block. So by writing multi-catch block, it can handle more than one exception that can be raised by a single piece of code that is written inside a try block. So two or more catch clause can be specified and here each catch block catches different types of exceptions. So as a reference, I have included www.javapoint.com and have taken contents from the textbook Programming with Java, a Primer, 3rd edition by E. Baragalur Swami. Thank you.